Today we will discuss the challenges associated with moving to the cloud, whether it's using virtual machines, virtual appliances, or other cloud services, and more importantly, how we can respond to these challenges with Palo Alto's various virtual firewall solutions. We will look at the sizing, scalability, and the principles of how these firewalls work, because it should be noted that there are some subtle differences between these cloud solutions and the on-premises ones. We will look at how we can install these firewalls in Azure, and we will explore Panorama, which is Palo Alto's centralized management solution. We will also look at modern use cases that are very prevalent right now with the pandemic situation that is going on, as many organizations need to let users access internal infrastructure from home via VPNs. Or, if you've had the foresight, you have already migrated to Microsoft's cloud ecosystem. As the title of this slide suggests, using the cloud is no longer a decision we can make. Instead, we are forced, for lack of a better word, into using cloud infrastructure in our organizations. You see more and more cloud-only solutions, even from organizations whose bread and butter was on-premises solutions. With the pandemic and the shift towards cloud computing, we have lost a lot of control over how we protect and manage our data. And with the use of cloud solutions, we need to ensure that the user experience is not degraded when compared with our on-prem solutions. Let's make it easier for users, let's make it more secure, and let's also reduce costs with well-optimized usage-based subscriptions. These principles are the reasons why you'll see newer companies that operate in purely cloud-based environments. Here we can see a very interesting statistic. On average, organizations are actively using 3.4 clouds and are experimenting with another 1.5. This means that the average organization has to secure nearly 5 cloud environments at the same time. And the public cloud is just as vulnerable to hackers as any on-premises IT infrastructure, if not more. It has become an extremely valuable target. Cloud environments are dynamic and often lack pervasive and 24/7 visibility, creating blind spots that can be exploited by hackers. Having to understand the security controls of 5 different cloud platforms is not an easy job. Misconfigurations due to this lack of understanding of security needs of new cloud technologies increases the risk of breach dramatically. Native public cloud security tools are limited and inconsistent between cloud providers. The learning curve can be steep and very labor-intensive, particularly since NetSec teams have to learn tools and policy models for multiple CSPs. When we start using cloud infrastructure, we introduce this idea of shared responsibility. Cloud service providers are responsible for securing hardware, operating systems, networking, and the underlying infrastructure of the cloud environment. Think of a classic server room and the hardware you'd expect to see in there. That is essentially what the cloud service provider is responsible for. An organization's security teams, developers, and DevOps teams are responsible for tasks such as configuration, user and credential integrity, network and host security, and importantly, data and application security. There is a clear delineation of responsibilities, and understanding this and acting on it is essential to reducing your organization's cybersecurity risk. Cloud service providers do offer native security tools to help you with your part of the shared responsibility model, although they can be substantially limited in what they can do. One of the challenges for network security teams is that each cloud comes with its own native security tools, often differing in their scope, capabilities, and ease of use. This means that it's incredibly difficult to enforce the same level of control consistently across each environment. Each cloud comes with its own policy models, making it nearly impossible to standardize policies across clouds. If I write a policy in AWS and I want to enforce that same policy in Azure, I have to recreate it. And each cloud comes with its own security management solutions, which means that network security teams have to bounce between interfaces and consoles continuously to effectively manage their overall security posture. Overnight, network security teams are faced with learning, deploying, and managing security posture for each cloud. A cloud platform security toolkit may include a layer 3 and 4 firewall, such as Azure's network security groups. These are limited to blocking or allowing specific IPs and ports. Most CSPs will offer some sort of layer 7 web application firewall, but this is typically closer to a reverse proxy rather than anything else. And as such, they cannot really replace a traditional web application firewall solution. Content inspection is limited to fully qualified domain name inspection and DOS protection. Their CTI sources are often very cloud specific, whereas we'd be better off with CTI tailored to our business processes. Network security teams lack visibility into traffic in a cloud network that they would otherwise have in an on-premises network. Native public cloud security groups are essentially access control lists and do not provide the level of visibility or control that network security teams rely on from their on-premises firewalls. The average organization is experimenting with over 3 public clouds and 1 or 2 private clouds, none of which have the same tools or network security policy models. With a solution like Panorama, you're managing your entire environment from one standardized console. When NetSec does try to implement additional security tools in public cloud environments, they struggle to find tools that can operate and scale as seamlessly as public cloud infrastructure itself. Security that doesn't operate at cloud speed and scalability renders the whole move to the cloud pointless. VM-series virtual firewalls provide consistent threat prevention and inline network security across cloud environments, helping network security teams regain visibility and control over traffic in their cloud networks. With Panorama, you're managing the security of your entire environment from a single, consistent, centralized point. VM-series offers all the same capabilities as Palo Alto's industry-leading hardware firewalls in a virtual machine form factor, making it highly automatable and scalable, a requisite for cloud environments. Let's take a quick look at how VM-series virtual firewalls complement and augment the native network security controls offered by CSPs. As you can see, the VM-series extends all of the native cloud controls in some very important ways. First is the so-called App ID functionality, which augments your network security policies beyond simple port-based rules to application-based policies. This ensures that every application traversing your network, not just HTTP or HTTPS applications, are identified independently of its port, protocol, or encryption. Similarly, you can create user or group-based rules as well, where you can synchronize your firewall with an Active Directory forest and detect which user a given packet originates from, and then decide whether or not to block the packet based on the user's role and privileges. We can also create geo-based policies. For example, if you only want people from your home country or perhaps neighboring countries to access your published service. Palo Alto's firewalls can also detect what zone a request originates from within your organization. You can create rules on this as well, which is especially useful for network segmentation purposes. As we know, 90 to 95% of websites use SSL encryption. Of course, these VM-series firewalls are equipped with SSL decryption capabilities, which is more of a requirement now with next-generation firewalls. Without it, the firewall would be very limited in its capabilities. The URL filtering service is another good example of how the VM-series goes beyond the native capabilities of a CSP's out-of-the-box security solutions. Most clouds provide basic FQDN filtering, which broadly limits access to a given website. But in cloud environments, it is necessary to grant access to said website so that some employees can effectively do their jobs. With the URL filtering service, you can specifically allow, say, developers to access the code repositories they need and block potentially malicious repos at the same time. VM-series virtual firewalls also enable advanced threat protection in the form of signature-based protection and the Wildfire malware analysis service, which protects cloud environments from both known and unknown threats. Data pattern filtering is also a possibility. For example, we can prevent users from submitting their sensitive information, such as social security information, to a phishing website. We can, of course, filter based on file extensions. The host information profiles functionality is almost comparable to something like network access control, except this isn't built into a switch, but rather a software solution. It essentially checks a number of characteristics of a host to determine whether or not to allow the connection. These characteristics could be having an adequate antivirus or an up-to-date operating system. We also get Palo Alto's threat intelligence feed, which is a nice addition. And last but definitely not least, we have the previously mentioned Panorama management solution, which allows you to manage VM-series virtual firewalls deployed across all of your cloud environments from a single console. Additionally, you can manage your on-prem hardware firewalls in addition to your virtual firewalls from Panorama. Let's take a look at some use cases for firewalls in public cloud environments. One could be perimeter protection. You could protect web-facing applications and internal developer environments from inbound and outbound threats, or perhaps you could have internal code repositories, the access to which you might want to monitor. You can segment between and within your VNets to reduce your attack surface and ensure compliance, and you can manage network security across clouds from one console. Basically, you are setting up just one set of policies to control your entire environment. Native public cloud security capabilities are limited to port-based controls that lack application context. CSPs are experts at providing scalable, automatable infrastructure, not best-in-breed security. Internet-facing applications, both web apps and non-web apps, must be protected from inbound threats from the internet. For this, we can use threat prevention, Wildfire, which is Palo Alto's sandboxing technology, and web-based policies to protect internet-facing apps from known and unknown threats. Another thing we need to protect against is exfiltration. To do this, we can use URL filtering and DNS security. Another use case is cloud network segmentation. The challenges here are security groups reduce attack surface but cannot prevent threats using allowed traffic. Compliance also mandates advanced security services to be inserted between network segments. The solution here is to use threat prevention and DNS security services between network segments to prevent lateral movement attacks. And our last use case for now is multi- and hybrid cloud security. The challenges here are that every cloud has different security capabilities and policies. Also, on-prem firewalls are managed separately from your cloud security. The solution here is Panorama. You'll hear about Panorama a lot during this presentation. With Panorama, both VM series and PA series firewalls are managed from the same console. VM series firewalls are elastic and scalable. You are provided with auto-scale templates, bootstrapping, and other automated configuration capabilities, in addition to flexible pricing that ensures VM series firewalls can be easily deployed to scale with increased demand. Equally important is the fact that VM series firewalls can be deprecated after demand has subsided to ensure that you aren't paying for unnecessary services. Integration with automation and orchestration platforms such as Terraform or Ansible allow VM series firewalls to be deployed as part of the application development process to ensure security at DevOps speed. A tag-based policy model, tight integration across multiple cloud infrastructure providers, and a fully documented XML API allow for the creation of flexible policies that can adapt to an ever-changing environment regardless of the underlying infrastructure. Unified management from Panorama simplifies network security management even across different infrastructures and clouds. A single policy model across on-prem, private, and public clouds reduces gaps in the overall security posture. Advanced security services deployed on Palo Alto firewalls reduces the need for any additional security products, thereby reducing complexity and making it easy to deploy the right security controls wherever they are needed throughout your environment. And most importantly, Palo Alto has an excellent reputation, a proven track record, and has been a leader in enterprise security technology for a good time now. We will now be having a look at the requirements and how exactly these firewalls work in a Microsoft Azure environment. First, let's take a look at the various VM series firewalls available. As you can see, licensing and cost is essentially based on the number of virtual CPU cores you would like to use. Obviously, with more cores comes more performance and throughput. This table shows the performance we can expect from these virtual firewalls paired with different VM sizes. Here we can see the various licensing models available. Bring your own license is the classic paradigm where, for example, you buy the license from a reseller, such as us here at Blackcell, and you install this license in an on-premises or cloud-based firewall appliance. Here you can choose to subscribe to various services individually or as a bundle. Under the subscriptions heading, you can see threat prevention, DNS security, URL filtering, Global Protect, and Wildfire. These are some of the services that you can either get individually or as a bundle, and of course the bundle will be cheaper. The pay-as-you-go model is only available for public cloud appliances. The name speaks for itself. You don't subscribe for a fixed amount of time, you simply pay for what you use. This is really useful for use cases that require automated scaling. Demand rises and you spin up more VMs, then you pay for those as well, and then stop paying for them when they are deallocated. This licensing model is done in bundles. You cannot individually subscribe to the various services. Lastly, there is the enterprise license agreement. Here you can basically utilize as many virtual firewalls as you would like. There are no restrictions placed on how many VMs you can spin up, and you pay a fixed price. Let's see how these firewalls integrate with Azure. As I mentioned in the previous set of slides, these firewalls are compatible with a number of automation tools for DevOps teams. Here we can see the previously mentioned Terraform and Ansible, and you also get access to the Palo Alto Networks Python library through which you can create scripts for automation. Azure scale sets are how we can dynamically allocate more firewall instances for when demand increases. To use scale sets, you must start with at least 2 virtual firewalls, but you can also set a maximum number of instances that you'd like to scale up to. Centralized management is provided through Panorama, and we can actually do nearly everything through Panorama. We don't actually need to touch anything in Azure. Azure App Insights integrates into the firewalls and reads various metrics such as VPN utilization or CPU usage, and for these metrics, we can set thresholds for when we would like scaling to happen. We can also avoid this whole process and deploy virtual machines into a scale set through Panorama without modifying anything in Azure. This is yet another feature that simplifies the workflow of managing our firewalls. Panorama can access various Azure APIs to detect the various objects in our cloud environment. These objects are tagged and policies can be applied and enforced based on these tags. This is great because, as we know, cloud environments are constantly changing and legacy methods of applying rules to, say, IP addresses won't react well to any changes in our environment. I just wanted to mention you can set up default configurations for when scaling up and deploying new VMs. However, if you do this process through Panorama, all of this is done automatically for you. The previously mentioned plugin that integrates with firewall instances to collect metrics also allows integration with Azure Security Solutions. More specifically, Azure Security Center and Azure's cloud-native security information and event management system called Sentinel. Let's take a look at how we can use VM series firewalls in our network architecture. Here we can see a /16 VNet with a number of /24 subnets. As denoted by the green arrows, the communication between the various subnets is unrestricted and the traffic is unprotected. As you can see, one of the subnets is exposed to the internet, so if something in this subnet is compromised, you've essentially exposed all your subnets in the entire VNet. To introduce a firewall into this environment, we need to create some user-defined routes. We will segment our network into trusted and untrusted segments. You can see we created 2 of these user-defined routes where the next hop address points to the firewall. This will mean that when entities in the 3 subnets try to communicate with each other, the connection will always be routed through a firewall. In our previous slide, we only had 1 firewall, which is fine for some applications, but often we would like to have scalability and redundancy. Some of you might be familiar with the little blue logo that has appeared on this slide. This is an Azure load balancer. We can natively set up load balancers in Azure, however we can just do this whole process through Panorama. One thing to note about high availability clusters in Azure is that we cannot create active-passive high availability clusters like we can in on-prem solutions, because everything in Azure is layer 3 and above, so we don't really have the concept of a MAC address to work with. Just like how we cannot reserve IP addresses with DHCP in Azure, because there's no MAC address for us to tie our IP to. Now back to our slide, we can see that our load balancer has an IP address that has become the next hop address. The load balancer will split the outbound traffic between the 2 virtual firewalls, also providing high availability. We can shut down either virtual machine for maintenance or other reasons without affecting our availability. Here we can see a slightly different paradigm. Instead of having 1 VNet with a number of subnets, we could just have multiple VNets. The central VNet our traffic flows through and contains our firewall is the hub, with several other VNets that connect through the hub. These are called spokes. The various VNets are connected via VNet peering. VNet peering is non-transitive, low latency, and routes are automatically exchanged. Let's now have a look at how a connection would be made originating from one of our spokes towards the internet. As I mentioned a moment ago, routes are automatically exchanged, thus the next hop address for our connection originating from a spoke will be our load balancer in the next VNet. The load balancer will then forward the request to one of our firewalls, and our firewall will perform content inspection and then release the request to the internet. The response will come back to the same firewall that forwarded the request, so there are no complications with sessions where the response comes back through a different virtual firewall. We can use layer 7 application gateways with services published to the internet. When a request comes from the internet, the application gateway will forward the request to one of the firewalls, which will then send the request to the appropriate subnet with the help of network translation rules. You can see this is pretty much just the reversal of the previous slide. The response will be sent back in the same way as we discussed before, no need to elaborate on this. Here we can see what happens when the communication occurs between two VNets. The request will go to the load balancer, it will get forwarded to the firewall, inspected, and sent to the recipient VNet. And it's vice versa for the response. We can also send the VPN traffic between the cloud and our data center or headquarters through our virtual firewalls. The connection from our data center goes through an Azure VPN gateway, which is part of our firewall's VNet. The next hop address will be our load balancer, which sends the VPN traffic through one of our firewalls before it gets forwarded to the relevant spoke.